in 3.2. Today we're going to solve linear systems algebraically. If I can spell that right. Algebraically. All right, so solving algebraically means we're not graphing today. Okay? So, and it's systems of equations, not inequalities. The only way we could do inequalities is by graphing, because it's a region, not just a specific ordered pair. Today is going back to the answer will look like an ordered pair. We'll get an X and we'll get a Y. Okay? So back in Algebra 1, we learned how to do it two ways algebraically. That means on paper, working it out. And those two methods were substitution method and elimination method. Do those ring a bell? Substitution and elimination. So that's what we're doing today. We have two variables. Tomorrow's lesson will be a lot more difficult because we will have three variables. We'll have an X, a Y, and a Z. Okay? So tomorrow's lesson is a lot more difficult than what today's will be. And the problems will take a very long time to do. Just warning you. So today we're going to stick to simple two variables, two equations. We're going to start with substitution. Turn the heat off. So we're going to start with substitution. Now, what substitution is when you have two things that are equal, you can replace one with the other. Right? That's what substitution is. If I have 4 quarters, that's the same thing as $1. Right? Right? And if I have 10 dimes, that's also the same thing as $1. So if I have something that costs $1, I can pay for it with 4 quarters. I can pay for it with 10 dimes. I can pay for it with 20 nickels. I can 100 pennies. Okay? I can replace it. They have equal value, so I can use one for the other. Right? That's what substitution is. Now, for substitution method, here's my 2 original equations for this one. What you want to, I'm going to put a box around my original equations because it's kind of important when you're doing a system to know what the original equations were. So what I want to do when I'm using substitution is I want to get a variable by itself. Okay? So if you look at this system right here, I have 4 variables, right? 2 X's and 2 Y's. 2 X's and 2 Y's. Now the one that's going to be the easiest to get by itself is going to be this X right here. Why do you think that one's going to be the easiest? Because it doesn't have a number with it, right? So it's actually the simplest X to be by itself. You need a pencil? You need a pencil? Okay. Well, you're not writing, so I just wondered. So what I would do is I would copy that one again. And let's get that X by itself. So how do we get that X by itself? Subtract 3Y. And it's just kind of like the opposite of slope-intercept form, the way it looks with the X and the Y in different places. Right? Because we solve for X instead of Y. So now, X equals negative 3Y plus 3. X equals negative 3Y plus 3. So anywhere I see an X, I can substitute negative 3Y plus 3 in for that X. So if you look at the top equation, it also has an X in it, doesn't it? So it says 2X plus 5Y equals negative 5. So what I can do is I can take this, where I got for X, and plug it in for X right there. Does that make sense? I don't want to use the second equation because that's the one I used to get what X equals. Okay?
So it would be 2 times negative 3Y plus 3 plus 5Y negative 5.
You said it. So 2 parentheses, because we're going to distribute, Negative 3y plus 3 plus 5y equals negative 5. Now, what are my variables? They're all y's, aren't they? I can't solve an equation with an x and a y for a specific number, but I can solve them if they're both the same variable. So that's what you're trying to do, is you're trying to get it all to be the same variable. So we're going to distribute 2 times negative 3y is what?
Negative 6y.
Yep.
6.
And then copy. And then these are like terms. So what's negative 6y plus 5y?
Negative 1. So 6 plus.
Yeah, you could have said 6 minus y, same thing. And then subtract the 6.
Negative y.
And then you can divide by negative 1. If you do that step in your head, that's fine. All right. So are there any questions about how we got y? Now, how do you think we're going to get x?
So the same thing. Right off.
You could. Or, since we already know over here that x equals negative 3y plus 3.
Plug 11.
Yeah, plug 11 in for y, and that's probably going to be the simplest way. So x is going to equal negative 3 times 11 plus 3, which is negative 33 plus 3, which is what?
Negative 30.
Negative 30. And to write your answer needs to be an ordered pair. You got an x and you got a y. So you'll come over here and say negative 30, comma y. Oh, no, sorry, comma 11. This is your x, this is your y. So no matter what order you answered them in, x, comma, y in parentheses. Solving systems takes time, and unfortunately, it takes paper. Okay? So that is substitution method. Let's do one more, and then you guys are going to try one. I want to make sure we really understand this stuff. I'm going to draw a line. Separate it. Problem B. 3x plus 2y equals 1. And negative 2x plus y equals 4. All right, we want to pick a variable and solve for it. Now, which one of those 4 variables do you think is going to be the easiest one to get by itself? Which y? Top one or bottom? The one on the bottom. Why is it the easiest one? It's already by itself. Very good. It don't have a number with it to divide away. So it's just one step less to do. So how do we get that y by itself? Think again. We're going to add 2x. So y equals 2x plus 4. So y equals 2x plus 4. And we use the second equation, right? So we plug it in for y in the top equation. Because y equals 2x plus 4, I can replace 2x plus 4 anywhere I see a y. Y'all with me? Okay. So top equation, I'm going to say 3x parentheses 2 times 2x plus 4 equals 1. And what do I have to do now? What am I going to do to solve for x? Distribute, right? So 3x plus 4x plus 8 equals 1. We like terms. 7x plus 8 equals 1. Subtract 8. 7x equals negative 7. Divide by 7, x equals negative 1. Now how do I get y? Plug the x in for right here. Okay? So y is going to be 2 times negative 1 plus 4. What's 2 times negative 1? Negative 2 plus 4 equals what? 2. And write your answer. You need x, then y in parentheses. So what's my x value? Negative 1. What's my y value? 2. Now what that means if the solution is negative 1, 2, is if I graph these two lines, if I put them in slope-intercept form and graph them, where are they going to cross at? At the point negative 1, 2. That's where those two lines cross. So that's what you're doing. You're just doing it algebraically instead of graphing it. Okay? I want you guys to try one on your own.
So would this method work on what we were just doing?
Yes. The thing is, your test or your quiz is going to be a quiz. On Thursday, we'll say solve using the graphing method, or solve using the substitution method, or solve using elimination. So you really need to do this method it says. Sometimes it'll say solve using any method, and you just look at the problem and see which one looks best for that problem. So, yes. And there are also good ways to check yourself doing that. Okay, so you guys try this one. Use substitution, please.
Did you use substitution or what?
I did. That's all we've learned so far. Unless you remember from last year. Or from 2 years ago, actually, for you guys. Use substitution.
Let's go.
What you got? All right, did you get x back? Okay. So x, you forgot the y. So it should be negative 5y. Okay, you got the y. It's negative 5y minus 9. And you plug that in for the x. This x equals that. So you plug it in for x. Anybody else saying something?
I have a question for you.
Go ahead.
What if there's not a variable by itself?
What if there's not? Then you would have to do a lot of work, and I will not give you a substitution problem that doesn't have one.
What if I'm curious? How do you read that?
It would just be an extra step. So, like, say you have, and if you want to, you get to pick which one you want to get by itself. So, say you want to get x by itself, you would do this. 2x equals negative 4y plus 8, and then you divide everything by 2. So it's just an extra step. And the extra step is where you divide both sides by that number. But if I had one like that, where there was not any variables by itself, I would use elimination. But so I'm not going to give you any that are not like that. We'll save those for elimination. All right, if you've got an ordered pair, I want you to check your ordered pair with a neighbor. Well, I'm fixing to go over it. I'm about to go over it. I didn't write down my answer. I'll look now. I'll check it. I worked it out earlier. What'd you get? Nobody want to tell me what I got? Okay. 2 letters. I said you are. And Spain. And most of South America. All right, so y'all help me out. So which one did you get by itself? X. The X on the bottom, right? Mm-hmm. So let me recopy that. And how'd you get the X by itself? Subtract 5y. So X equals negative 5y minus 9. And then you plug it in where? For the X on the top row, right? And then you distribute, and you should get negative 20y. Right, and this is like terms right there, so that's negative 17y minus 36 equals negative 2. I'm going to add 36 to both sides. Negative 17y equals 34. Divide by negative 17. And y equals what? Negative 2. And then you should have plugged that in for the x over there. X equals negative 5 times, plug it in for y, I mean, negative 2. Negative 5 times negative 2 minus 9. And that's negative 10 minus 9. X equals negative 19. So that ordered pair is negative 19. What did I do wrong? A negative times a negative is a
positive.
Yeah. And negative 10 minus 9, or positive 10 minus 9 is what? 1. And the ordered pair is what? 1 negative 2. Something like that. Okay. All right. Any questions? All right. So let's talk about eliminations. One negative 2. Elimination. Now, when we use elimination, it's kind of fun because we get to kind of cancel something out. And I always think it's fun in math class when we get to cancel something out and do away with it. It usually makes our life a little simpler when that happens. So, elimination method. You got your system. This is example what? See? 8x plus 2y equals 4. And negative 2x plus 3y equals 13. I'm going to put a box around my original problems. All right. So when you eliminate a variable, what you want to happen is you want to have the positive variable with the exponent, with the variable, and the negative with the same coefficient. So, for example, I want a positive 4x and a negative 4x to cancel out. Okay? Or I want a negative 2y and a positive 2y. So if you have that going on, you can cancel out a variable. Now, we don't have that set up right here on this problem, do we?
No.
I got a positive 8 and a negative 2x to cancel with, or a positive 2y and a positive 3y. So they got to be with the same number, with the same variable, but opposite signs. So first, I want to talk about these x's. They don't cancel out yet, but you want to think of a number that you can multiply a whole entire row by that would make them cancel out. So is there something I can multiply times one of these rows to make it where it's the same thing on both, but opposite signs? You may think of anything? So let's just look at the x's. Ignore the y's because the y is going to make it complicated on this one. Say I want to eliminate the x's. So if this one's a positive 8x, what would I need this one to be to cancel out with positive 8x? Negative 8x, right? So how do I make this negative 2 change into a negative 8?
Divide.
Not divide. Multiply it by 4. Very good. So I'm going to multiply that whole row right here by 4. So I'm going to copy 8x plus 2y equals 4, and then I'm going to distribute and get negative 8x. Now I got to do it times all three terms. 4 times 3y is 12y, and 4 times 13 is 42. No, it's not.
I'm lost.
I'm lost too.
Okay. This is, okay.
We just multiplied the 2x plus 3y equals 13.
Yes.
That turns into negative 8x plus.
Yes, I copied this one. This is exact same as the first row.
Why we put the first row up there?
Because I need them on top of each other to cancel them out. Because what I'm going to do is I'm going to combine like terms, add downtown like you did in first grade. Because you got to combine them both together. Okay, so I'm going to do it like you did first grade, second on top of each other. Okay, so to get the x's to cancel out, I had to multiply one row by something because I had none of them that were already a positive and a negative of the same term. So for my x's to cancel out is because they add to make 0, right? Positive 8x minus 8x makes 0x. So that's how x's cancel out. Okay? So now, that's why I multiplied by 40. Y'all get that? Okay. So I could have done the same thing with the y's, but made one of them a positive 6 and one of them a negative 6. Okay? But that would have taken me multiplying both rows by something, which is more work. Okay? So since 2 went into 8, that's why I stuck with my x's. Does that make sense? Y'all, this just takes practice. The more we see of these, the more you're going to get it. Because we're eliminating the whole rest of the week.
Okay, so there's no x, so.
No. These cancel.
So add the y.
Add the y's and add the constants over there. Those are called constants.
14
Y
56.
equals 56. And then I divide because it's a little bitty equation now.
No, since you times that by 4, you gotta take that 4 away at some point.
No, you don't. Because I did it to the whole equation. I did it all the way across. You did this in Algebra 1, I promise. And then you did 56 divided by 14 is what?
4.
No, it's not 4. Yeah, it is.
Oh, baby.
Yeah, it is.
I was going to say
It is 2. So y equals 4 is 4. So y equals 4. So then you can do just like you did earlier. We know y equals 4. We can substitute it and just put it in the top equation and solve it for x. So 8x plus 2 times 4 equals 4. So 8x plus 8 equals 4. Subtract 8. 8x equals negative 4. Divide by 8. X equals negative 1/2. So my ordered pair is negative 1/2, comma 4. And it's okay if you get fractions, just simplify. So let's just walk through this out loud. With elimination, you're trying to get a variable to cancel out. So that means you need a positive and a negative of the same number with the same variable, x or y. Okay? So you're going to multiply the rows to get it to work out that way. Okay? And then when you do that, you get to solve. One of the variables cancels out, so you can solve for a variable, and then you plug that into one of the originals to get the other variable.
The other way is not something good.
It might be. On some of them it is, and some of them it's not. All right.
Okay, so the other one you call that elimination.
Elimination. This is elimination. The first one was substitution. I'll try. Okay. So let's try another one. Let's try this one. Okay. We're going to try elimination again. Now, I don't have a variable ready to cancel out yet, right? Because when they're ready to cancel out, I have a positive and a negative of the same number with the same term. Okay? So, now let's think. Is it going to be easier to cancel out the x's or the y's?
The Y.
Well, just think about it. If one of them goes into the other one, that's usually the easiest one. Yeah. So, the y's, actually, the only number that 7 and 8, the smallest number they both go into is 56. So that's going to be a long process because I'd have to multiply one row by 8, one row by -7, and it would just be a lot of multiplying. So I can multiply what on top to cancel out my x's? -2. Why are we going to use -2? So they'll have opposite signs, right? Does that make sense? This one's positive, so I need this one to be negative. So that's why I'm going to use -2. So is everything good? Everybody good on that? The box are on my originals. All right. So I'm going to distribute a -2 to all three terms on the top row.
Negative.
Go ahead.
6x minus.
Try again.
Plus 14y equals 20.
-20. And then copy the other row. If you don't multiply it, you copy it. Draw your line. And what happens to my x's?
6y.
Cancel out. And I add my y's, and I get 6y equals, what's my constant? Y equals -2. And how do we get our x value then? Plug it into either one of the originals. I'm just going to do the bottom original because I don't have a bunch of stuff around it. So I'm going to say 6x minus 8 times -2 equals +8. And 6x plus 16 equals 8. Subtract 16 on both sides. 6x equals -8. And we're going to reduce that. -4/3. -2. And it's okay that we get fractions. Just reduce them. How about this next one? Because I know it's confusing to look up and look down, look up, look down. How about this next one? You guys just participate with me out loud and just watch me, and then you can try the next one on paper. That sound good? Well, if you want to write it, you can write it. Well, we just got to try. Practice makes perfect. Actually, perfect practice makes perfect, to be honest. All right, let's try this one. Okay, there's my originals. So y'all help me decide if we want to eliminate the x's or the y's. Yeah, because the smallest number that 6 and 7 both go into is 42. And what's the smallest number that 3 and 4 both go into? What is it?
See, that's my problem. I've never been good at factoring.
Right. Don't know what I'm talking about.
I never learned that factoring skills. I just slept through that part.
Not good. We need those skills very badly. All through Algebra 2. All right, so the smallest number that 3 and 4 both go into is what? 12. So we're going to make one of them positive 12 and one of them negative 12. All right? And since they're already opposite signs, we can just multiply by positive numbers, and that's easy. Since they're already opposite signs. So what times 3 makes 12?
4.
4. So we're going to multiply top row by 4. What times negative 4 makes negative 12? 3. Okay.
So all you have to do is just multiply it by opposite, right?
Not necessarily.
So we use 3 and we use 4 then.
That time we did, yes. If there's nothing they have in common that both go into them, then yes. But like 2 and 6, 2 goes into 6, so you'll use 3. Does that make sense? Sometimes yes, not all the time. Okay. I know y'all want math teachers to say, you always do this. But that's not the way math works. All right, so we're going to distribute times all 3 terms. Y'all, a common mistake is forgetting to multiply times this last term over here. So 4 times 3x is 12x. 4 times negative 6y is negative 24y. Equals 4 times 9 is 36. Good. And we'll do the bottom row. 3 times negative 4x is what? 3 times 7y. And 3 times negative 16 is what?
42.
Negative 40.
Negative 40.
Negative 48. Okay.
Multiplying wasn't good at me.
Cancel out the 12x.
Yep. And what's negative 24y plus 21y?
43.
They're opposite signs.
Negative 3.
Thank you. And then 36 minus 48 is negative 12. Divide by negative 3 and y equals positive 4. So how am I going to get x? Plug it into one of the originals. My original ones are in black. All the red stuff was my work around it. So I'm just going to do it into that 3x minus 6y equals 9 for the y. So 3x minus 6 times 4 equals 9. So that's 3x minus 24 equals 9. I add 24 to each side. So 3x equals what? 33? Divide by 3. And x equals what? 11. So what's my ordered pair here? 4. Okay. I want y'all to try one. No, that was the one y'all helped me with. Oh, trying means you have your own paper and you take after it by yourself. 3x plus 3y equals negative 15. And then 5x minus 9y. I'll try that one on your own.
All right, got a question. Can you ever divide instead of multiplying by numbers?
Did I see what you're getting at?
Can you help me with the first one?
Because if we divide, we'd still have to multiply to something to cancel out with 5.
Can you help with the first one?
All right, what you think?
I think I really think.
You actually want to eliminate the y's this time. That might help y'all. Eliminate the y's, y'all. It's a lot easier. Because don't one of them go into the other? All 3 going on. Yeah. No, I did what? Say like 3 goes into 9 3 times. Then make this one a positive 9 while I do that. I'll talk about that. Try that.
Want to do the bottom, do
No, just copy the bottom.
it. 9x.
These calculators switch from decimals to mixed
Mix
numbers. Why you give me like 10.5? So like how would you write that?
math interview. You got 10.5. They double checking that.
I felt, I got the X this time before I got it.
That's because we're canceling out y's first.
And then, alright, so it.
Keep going. What'd you get for x?
-3.
Keep going. You're doing good. -3 is correct for x. It's probably something so simple. Mm-hmm. Sometimes it's as simple as a negative sign or a positive sign in the wrong place. I sure can. You don't have to multiply both rows by 3. You don't have to multiply the top row by 3. Okay? So the rest, change your bottom row to match exactly what it started with. And then keep going. I don't care. Just a few more seconds. A few more people are finishing up. If you're done and you want to check with a neighbor that's also done, you can whisper and check. Don't say the answer too loudly. If y'all want to check with me, you can get me to come check. Come here. Missy. Oh, you're so close. What did you do? You plugged it in for X into the first one. And then you said, let me see. What's 6 divided by 3? No. Which one did you plug it into?
The 5.
The second one?
Mm-hmm.
15. Okay. Oh, wait a second.
I said 12 divided by 4.
You did.
That should be 12 divided by 9.
No, 12 divided by 4 is right.
It shouldn't be. Because you got the 9 y.
Should be negative 15. I don't know what we're doing wrong.
12 divided by 4.
It's 3. But let's see, why is this doing something different?
Did he?
Let me see. It's 3. 5 minus 1. Negative 9.
Well, it ain't gonna be
Yeah.
a difference because he plugged in for the bottom end.
No, it shouldn't be. But this one is coming out different.
I did my math right?
Yeah.
Okay.
This book's got a misprint in it. 5 times negative. Oh, you didn't do 5 times negative 3. You should have got negative 3 for your x. That's it. You should have got negative 3.
Mm-hmm.
Let me see where you missed that one. 3.
These things negative.
I know, they'll mess it up. Right here.
Oh,
Yeah, it's over there.
that's how it.
Mm-hmm. That should have been negative 42. Yeah. Yeah, a simple negative sign can mess everything up, guys. So let's work on this one together. So I hinted to y'all that probably the best way to do it is to eliminate your y's because 3 goes into 9. So I would have multiplied my top row by 3 to eliminate my y's. And when I did that, I would have got 9x plus 9y equals negative 45. And I would have kept my bottom row the same. And now my y's cancel, which I know all of our examples previous, we canceled the x's, okay? But you do it the same way. 9x plus 5x is 14x equals negative 42. Divide by 14. X equals negative 3, right? And then you should plug it into one of the originals. I'm just going to do the bottom. 5 times negative 3 minus 9y equals 3. Negative 15 minus 9y equals 3. I'm adding 15 to both sides. Negative 9y equals 18. Divide by negative 9. And y equals negative 2. If you plugged it in to the top one, you should have got negative 2 also, even if your work looks different right here. Okay? So our work might look different from each other, just depending on where we plug stuff in. So raise your hand if you got the ordered pair, negative 3, negative 2. Very good. All right. There's 2 more special scenarios I have to show you real quick before we're done today. I know it's a long lesson today, but these problems just take a while. All right. But these are really quick. And they're not as strenuous, I don't think. So x minus 2y equals 4. And 3x minus 6y equals 8. Now, we can eliminate or we can substitute, okay? It's not really telling me which way I have to do it. If you want to use substitution, I would get this x by itself. If you want to use elimination, that's what I'm going to do just because it's easier on this problem. So y'all tell me, do y'all want to eliminate the x's or y's?
What is?
The x's. Okay, so if I'm canceling out with 3x, what do I need this one to change to? Negative 3x. And this is the understood 1 right here, right? So to get that to cancel out, I multiply the top row by negative 3. Now, if you notice, something fishy is going to happen right here. Okay, something fishy is going to happen. So if you're looking ahead and you see something happening that's a little crazy, it's supposed to be that way. So negative 3 times x is negative 3x. Negative 3 times negative 2y is a positive 6y. And negative 3 times 4 is negative 12. And the bottom stays the same. Well, what do y'all notice is happening?
They trying to turn out the same.
Both variables cancel, don't they? The x's cancel because I have a negative 3x and a positive 3x. And the y's cancel because that's the same way, a positive 6y and a negative 6y. So on this side of the equal sign, I just put a 0. Equals. What's negative 12 plus 8? Negative 4. Is that true or false? Does 0 equal negative 4? That's false. So if we have a false statement and our variables cancel out, our answer is no solution. What does that mean, no solution for a system of equations?
That those points will not cross at those.
That means that these two lines never cross each other. Because remember, the solution to a system where two lines cross. So if two lines never cross, what kind of lines are they? They're parallel lines. So these lines, if I would have put them in slope-intercept form, they would have the same slope. They would never cross each other. Okay? So that's one weird little thing that could happen. Here's another one. We're going to do a little work on this one. But it's still not going to be as bad as normal. Okay. I think I want to eliminate my x's. Because the smallest number that 4 and 14 both go into is 28. But the smallest number that 10 and 35 go into is 70. Right?
So how do you find functions? Just multiply the numbers together? 4 times 14.
Yeah.
Will be 50, 56.
No, but the smallest number they both go into 28, though. That's what I do. I try to find the one that's the smallest number they both go. It's like getting a common denominator.
What if you don't always get the smallest number?
Then you're just going to have bigger numbers when you multiply. Okay. It's possible to do it that way and get it correct. You'll just have bigger numbers to do it. Yeah. So the smallest number these both go into is 28. The smallest number these both go into is 70. So I'm going to use my x's. So to get 4 to be 28, I multiply it times what? 7. And to get negative 14 to be negative 28, I multiply it by 2. And that's so much better than multiplying by 10 and 7. Well, I did multiply by 10 and 7. Specialness here. Look here. Same thing's going to happen, sort of. Distribute, I get 28x minus 70y equals 56. And on bottom, I get negative 28x plus 70y equals negative 56. So what happens here?
Everything cancels out.
Everything cancels, so I have 0 on the left. Equals what? What's 56 minus 56?
0.
0. Is that true?
Yeah.
Yes. And so if variables all cancel out, and we're left with a true statement, which would be 0 equals 0 every time, you're going to say infinitely.
That means it's the same one.
Yes. Infinitely many solutions. Which means these two lines are the exact same line. Infinitely many solutions are two lines on top of each other. So the reason they are infinitely many solutions is they touch each other an infinite amount of times. They touch all the time because they're the same line. They're graphed right on top of each other.
Might touch right now.
They might, yeah, they are. Those two lines are touching forever.
Yeah.
All right. So, any questions about no solutions or infinitely many solutions?
No.
No homework.
Now these are rare, but you'll be glad when you get them because they're less work, right? They're rare, but you'll be glad when you see them because they are less work. So for our practice, now how are we gonna get good at this?
Perfect practice makes perfect work.
Yeah, just practice it and check your answer in the back of the book. That's why we have answers in the back of the book on odds. On the odd ones,
What we doing now?
you're doing a mixture. But I'm fixing to take some of them off if y'all be good for a second. For substitution, I want you to do problems 3 through 8. Page 164. Thank you. For substitution, you do 3 through 8, and for elimination, do 15 through 20. Use the method it says to use. Follow your directions. Tomorrow we will do elimination with 3 equations and 3 variables. So it's going to get serious tomorrow.